Hello students, as we have completed all the topics of chapter number 10, light, reflection and refraction. So today we are going to take some important points which is very necessary to do calculations related to mirror formula and lens formula. First of all, we must know that what is mirror formula. Okay, so what is our mirror formula? In mirror formula, the relation between u, v and f, okay, for mirror will be considered as a mirror formula. Our mirror formula will be 1 by u plus 1 by v is equal to 1 by f. So we have seen this as our mirror formula. So for a mirror, the formula which gives relation between u means object distance, v means image distance and f means focal length is called mirror formula. Second, which is important for sums, that is our lens formula. In lens formula, same way, for lens it's a relation between u object distance, v image distance and f focal length for lens. So we will get our lens formula 1 upon v minus 1 upon u is equal to 1 upon f. So this equation gives us relation between u, v and f. So this is considered as our lens formula. Now we will have different type of sums in that we have to use our mirror formula or we can use our lens formula. It is dependent on which type of question it is asked. The another important thing for sum, that is power of lens p. P, it will be equal to 1 upon f. Okay, so this is also the important formula for doing calculations of this particular chapter. If any of numerical is asked, right, unit of power, that will be diopter or it will be meter inverse. Okay, also we can say that r, radius of curvature, it is equal to twice of focal length. Radius of curvature is equal to twice of focal length. So this must be also in our mind. Now when we are calculating the sums which is related to power, so power can be positive also and negative also. Okay, so for convex lens, for convex lens our power will be positive. Why? Because the focal length is positive for convex lens. And if we have concave lens, for that the focal length will be negative. So here we will get it as negative. Yes, you remember that how we can consider the focal length is positive or negative. For that we have to use sign convention. We have taken different sign convention. Similar sign convention for mirror and sign convention for lens. For mirror, all of the distance is considered from pole P, and for lens all of the distance are considered from optical center O. So in mirror all of the distance is considered from pole P and in lens it is considered from O. Means the origin, if we have mirror, so it will be at point pole P, and if we have lens, so it will be at optical center. Okay, so suppose here we are having our pole or our optical center. Now don't get confused, understand very well. If it is at negative x-axis, if the distance is taken at negative x-axis, so that will be considered as negative, it will be minus. If it is at positive x-axis, means right side, so that will be plus. If the height is above the principal axis, that will be positive, and if the height is below the principal axis, so that will be considered as negative. So again, if it is in minus x direction, if the distance is in minus x direction, so that we will have negative. If the distance is it in positive x direction, so that will be always positive. Here you can say that left side and right side. If the height is above the principal axis, right, so that we will take as positive. Means if it is above the principal axis, so that will be considered as positive, and if it is in negative y direction, so that will be our negative. Means if it is below our principal axis, so minus x-axis negative, plus x-axis positive, plus y-axis positive, and minus y-axis, that will be negative. So when we are calculating any of sum which is related to mirror or lens, we will always follow this type of sign convention. Keep that in our mind. See, in different type of sums, they can ask us that how the image will be. For that, we must understand the magnifications concept. As we have understood the magnification concept, and according to that, there will be three conditions. First, m is equal to 1, m is greater than 1, and m is less than 1, right? We have taken this three condition, that in some cases m is equal to 1, in some cases m is greater than 1, and in some cases m is less than 1. Now try to understand that magnification. If we take magnification in mirror, so it is a ratio of height of image through height of object. Okay, again, magnification for mirror, it is ratio of height of image to height of object. Height of image to height of object. And if we want to take this in term of object distance and image distance, so that magnification will be also equal to minus v by u. For mirror, it will be minus v by u, and here the negative sign, it indicates that our object, we will place it at left side. Now when we are talking about magnification in lens, so in that case it is same, the definition will be same, the ratio of height of image to height of object. Okay, and if we consider magnification with image distance and object distance, we will get it v by u. Again, for mirror we will get minus v by u, and for lens we will get v by u. So from this we can say that how our image will be. So just focus here. We can prepare one table, and according to that table we can know that which type of image we will have. Suppose as we take m, so m can be equal to 1, m it is greater than 1, or m it can be less than 1. So if m is equal to 1, or m is less than 1, or m is greater than 1, what does it means? When m is equal to 1, and m means what? M is equal to h dash upon h. When this will become 1, when this both are same, means here we will have same size of our image. If m is greater than 1, so when m is greater than 1, it means this numerator must be greater. Okay, so when this numerator is greater, means h dash is greater, means how we will get our image? We will get magnified. We will get magnified image or magnified image. Okay, we can call it as magnified image or magnified image. M is less than 1, in that we will get diminished image. Why? Because when it will be less than 1, when your numerator is high and your when your denominator is high and your numerator is low. So numerator low means h dash low. Now h dash is low, it means height of image is less in comparison to height of object. So in these three cases, when m is equal to 1, our image will be same in size. When m is greater than 1, it will be magnified. When m is greater than 1, it will be magnified or enlarged. And when m is less than 1, we will get diminished or small image. Now in this case also, we will have that sometimes m is positive, and what happens when m is negative? Now keep this in our mind. When value of m is positive, it means our image, it will be virtual, and when value of m is negative, our image will be real. Again, when m is positive, our image will be virtual, and when the magnification is negative, our image will be real. Now let us understand it by one example. Suppose if I say that m it is equal to -3 for any of one object. If m is equal to -3, what does it mean? How we can get knowledge of the image which is formed? So first of all, let's check what is the sign. It is negative sign. Negative sign means how the image will be. Our image will be real. So our image will be real. As we know that it will be real, so real and inverted. So from this sign we will use to know our image is real and inverted. And now check this 3, what it is? It is greater than 1. 3 is greater than 1. So it follow the second condition, that if it is greater than 1, so our image will be real, inverted and enlarged or magnifying. Now let's take the another case. If I say that m that is equal to 0.25 or 0.25. Now see, value of m is positive. It means if the value is positive, our image will be virtual. As it is virtual, so it will be erect. And 0.25, sign will give us the nature and value, magnitude will give us the size. So it is positive. So positive means it will be virtual and erect. And 0.25, that is less than 1. 0.25, that is less than 1. So our image will be small. Right? So this way, when we are calculating the sums, we have to see that which type of image is formed. So let's calculate one sum according to that. Okay, let's calculate this sum. A convex mirror is used for rear view of an automobile, has a radius of curvature of 3 meter. Okay, so radius of curvature is given and we are having convex mirror. So we can assume it like this, that like this we are having convex mirror, and from the mirror the radius of curvature, it is 3 meter. So we can say like this, that the radius of curvature, that is 3 meter. From that we can get the focal length, because r is equal to twice f. So f is equal to r by 2. We'll get 3 by 2, that will be almost 1.5 naught meter. So this is our focal length and this is our radius of curvature. Okay, now see, if a bus is located at 5 centimeter, so from here the distance is 5 meter, it's given, it's not 5 centimeter, it is 5 meter. So this distance is our 5 meter. So our object distance u is given, that will be 5 meter. But as you can see that it is left side. Okay, so according to sign convention, it will be -5 meter. Okay, so whenever we are calculating the sum, sign convention is very necessary. From this we have to find out the position. Position means we have to find out the image distance, right? Means we have to find out the v. Then what we have to find? The another thing which we have to find is nature and size. Nature and size we can find out with the help of only magnification. Now let's try to solve it. First we have to find out v. We are having mirror, so we can use mirror formula. 1 upon u plus 1 upon v is equal to 1 upon f. We know this. Now we want v, so we will take this 1 upon u at right hand side. So we will get 1 upon v is equal to 1 upon f minus 1 upon u. Again, that's why 1 upon v is equal to u minus f upon uf. Okay, simple. We are taking LCM. Now we want v, so just do reciprocal of it. So we will get v is equal to u into f upon u minus f. Let's see. Now let's place the value. V is equal to, what is value of U? That will be minus 5 meter. What will be value of F? It is 1.5 knot. U, again it will be minus 5 minus value of F. It is at right side, okay, so that will be positive only, 1.5 knot. Now just do the calculation. What we are going to get? V is equal to 1.5 into 5, and that is negatively signed, so we'll get minus almost 7.5, right? And here minus 5 minus 1.50, so here it is going to get add, so here we will get, it is minus 6.5 knot, here 7.5 knot and here 6.5 knot. Now both are negatively signed, so it will become positive, and by the calculation we will get our answer. So V will be equal to 1.15 meter. It means we are getting our image at 1.15 meter. Now this, what we got only the position of the image, okay. Our image will be at 1.15 meter, right, from the pole. So at this side it will be 1.15 meter. So we got the position that where our image will be. It will be at right hand side, because here you can see the answer we are getting positive, so it is at right hand side, and this distance it will be 1.15 meter, okay. So at 1.15 meter we will get it. Now we have to find out nature and size. For that we have to find out the magnification. Now how we can do it? It's very easy. M, it is mirror, right? We don't have height of image or height of object, but we have value of U and value of V. From that we can do. So let's try. Magnification for mirror, that is minus V upon U. Now we got minus value of V, it is 1.15, right? And U, what is value of U? That will be negative sign with magnitude of 5.00. Negative, so that will become plus, and when we will calculate this, it will be 0.23. See, this positive sign means what? Our image will be virtual and erect, okay. Positive sign shows that our image will be virtual and erect. And see, this magnitude, it is less than 1. So as we have studied the condition that if it is less than 1, so our image, it will be smaller than the object, okay. So by this we can know whatever is asked here. Find the position. We have find out the position, so we can write here image will be at 1.15 meter at right side of the mirror. So we got the position, okay. And its type, how we got its type? By finding magnification. We got answer in positive, it means image will be virtual and erect. And how it will be? Its size of the image, it will be, and it will be smaller than the object, okay. So in today's lecture we have taken a revision of some terms which are very necessary to calculate the sum. Here I have calculated this one sum. You are going to calculate this sum according to this in your notebook, okay? And whatever worksheets are provided to you, you are going to solve that worksheets from the video, from video 1 to video 7, as already you have studied, and you have also written the worksheets, you have also solved the assignments. So by using that, right, you can solve today's assignment and you can do the homework.